Let me show you how to process data using DataDemon now. Let's load the data first. Right-click the mouse in the network panel and choose Source, Open Data. The data used in this demo is a 30-second continuous blood press recording which is sampled at 50 Hz. Choose the input data file, then the text importer window pops up. Specify the rows from 1 to end, and the columns from 1 to 1, since the data file only contains one column data. And then specify the sample frequency to 50 since the recording was sampled at 50 Hz. Then click the import button to read in the data. Select the data source signal flow object, also known as the SFO, right-click on it, and select Viewer, Data Viewer. The right panel of the data viewer shows the statistics of the data, including the histogram, data points, data duration, minimum value, maximum value, average, and standard deviation. With the data viewer, we can visually check whether the calculation of SFO is corrected. The data viewer also provides the data information for further analysis operation. After we are satisfied with the data, we can show it in the channel viewer. We do this by right-clicking on the data SFO, selecting Viewer, Channel Viewer. We can also do a simple Fourier transform on the data to check out its properties on the frequency domain. Select Compute, Transform, Fourier Transform, and we check the results of the Fourier transform by opening the data viewer of the FFT SFO. The dominant frequency is at about 1.5 Hz, which corresponds to the heart rate of 90 beats per minute. The other beats are its harmonics. We can also show this result in the channel viewer. Lastly, let's do time frequency analysis on the data. Select Compute, TFA, Short-Term Fourier Transform, and then show the result in the time frequency viewer. The x-axis of the time-frequency graph is time, and the y-axis is frequency. The color represents the power of Fourier transform. The red color represents large power value, and the blue color represents small power. After selecting STFT-SFO, we can change its properties. Frequency max to 8, and frequency resolution to 1.25. Now the results are more clearly shown in time-frequency viewer. We can see that the dominant frequency is quite stable over time. Now for a short intro on DataDemon's windows. Here I already have DataDemon open on my desktop. DataDemon's user interface is very simple and consists of 3 windows. The main window, which is the visualization window, and also the network window and the properties window. Each window can be shifted around to make the interface fit your personal preference. DataDemon's windows can be double-clicked to pop out and will pop back in when double-clicked a second time. The windows can also be dragged and dropped over position icons that will appear when a window is clicked and held. Windows can also be combined to be viewed through tabs like such. To return the window to its original position, double-click on the window to pop it out, and then place it over the corresponding position icon.